Hi everyone, thanks for joining. I'm Will Cooper and I work with the MSP430 product marketing team at Texas Instruments. Today I'm here to tell you about an exciting new series building on the FRAM MCU platform from Texas Instruments. The MSP430 family is expanding the ultra-low power line of FRAM microcontrollers with smaller memory footprint options and several newly integrated peripherals. Over the course of this training, we will go over an overview of the FR2x and FR2x series, dive into the clocking and core modules on the devices, and then go into the key peripherals such as the LCD controller, ADC, IR modulation logic, and input-outputs. Lastly, I will give you a look at the available tools and software to help ease development for engineers. So let's take a look at the overall series. The new MSP430 FR4x and MSP430 FR2x series help address similar concerns to the rest of the FRAM series. In terms of energy consumption, the MSP430 microcontroller family is continuing to lead the industry. The MSP430 FR4x and MSP430 FR2x microcontrollers offer ultra-low active power. Beyond that, these MCUs offer a real-time clock standby mode for 770 nanoamps, and the MSP430 FR4x can add LCD controller functionality while still consuming under 1 microamp. Next, when it comes to debugging, Energy Trace technology is available on these new series and every other MSP430 MCU for that matter. It is a power profiling technology that allows developers to debug current consumption in real time. This is in addition to reduced complexity with a new LCD controller and IR modulation logic that can simplify designs. The LCD has software configurable pins, so one design can be used for multiple LCDs, and LCD layout on a PCB is that much easier. IR modulation logic limits the software overhead in applications such as remote controls. On top of that, FRAM itself lends itself as one of the most simple and flexible non-volatile memory technologies. Lastly, and this really speaks to TI's ability to release a full portfolio of products, this platform will support devices that are memory scalable across the full range. There are new MCUs in the 4 to 16 kilobyte range with 3 different package options releasing now, and over 100 FRAM-based devices in total to address a large number of applications. Now, before we take a closer look at the portfolio, let's address FRAM at a deeper level. FRAM is a non-volatile random access memory. It stores data as a polarization of ferroelectric material based on the applied electric field. This does not require a charge to be stored, which can give it several advantages over traditional flash devices. So what are those advantages? First, you can simply write more. FRAM is much faster to write to than flash and has near infinite endurance. This means that in a remote sensor, data can be written more often for improved data accuracy, or it could collect data for longer. Second, FRAM lowers power. Due to lack of a charge pump, FRAM enables lower average and peak power during writes. It actually consumes as little as 250 times lower energy per bit than flash. Last, FRAM is a unified memory. This bitwise programmable memory can be used at the programmer's convenience for data or program storage. It also doesn't require things like pre-erasure of segments before the write. If you're concerned about migration guides, code examples, and even application notes are available to make getting started easy. The basic advantages are clear, but there are actually a number of other benefits as well. FRAM is reliable. It has actually been around for many years now as standalone memory. It has over 10 years of data retention at 85 degrees C and is resistant to electromagnetic fields and radiation. This means it can be used for development without worry. We have an FRAM quality and reliability guide on our product pages that can be used to get the specifics. Security is another area where FRAM can offer advantages. It is inherently more secure due to its makeup. In fact, delayering is not effective. Plus, quicker key generation and renewal is possible when using encryption due to the fast write speeds and high endurance. Quicker speeds also means less time to observe and hack a firmware updating process. Other benefits come during and after production as well. Quick writes can mean reduced time in a manufacturing line and can mean minimized power consumption of a system with shortened over-the-air update times. Here's a chart that summarizes the FRAM advantage versus memory technologies. As you can see, FRAM excels across the board. You can store data without power since it's non-volatile, can write faster with lower energy, and can write more. On top of that, it is resistant to soft errors and offers unmatched flexibility with bitwise programming and flexible storage of information. Now that we took a closer look at our FRAM memory technology, let's explore the portfolio built upon it. Here you can see that these new MSP430 FR4x and MSP430 FR2x series are filling in the lower memory footprint of the portfolio with a range from 4 to 16 kilobytes of non-volatile FRAM. On top of that, they feature a serviceable 10-bit ADC for reading analog sensors and feature unmatched input-output pin density for the memory size with up to 60 that are capacitive touch enabled. These devices also feature infrared modulation logic, and the MSP430 FR4x series adds on a 256 segment LCD controller. So let's look at the FR2x series. It features again up to 60 GPIO that are all capacitive touch enabled. In addition to that, it has new IR modulation logic, which will simplify IR design in things like remote controls, and it will reduce development time. This is all built on our FRAM platform, meaning that you can write faster with lower energy than you could with flash-based devices. These devices are going to be great for different applications ranging from smart metering to remote controls and smoke detectors. We have tons of software and tools to get you started, and stay tuned for the later section of this series to learn more. The MSP430 FR4x series is going to take all the great benefits of the FR2x series, but add on LCD. So what you'll find here is a 256-bit LCD that has an integrated charge pump for maintaining contrast in low power modes, and it's super flexible. So you can actually take this LCD and use software to configure the pins so that you can lay out the LCD however you need to. This set of devices will actually have an FR4 launch pad, which will be the first LCD-enabled launchpad, as well as target boards so you can get started. Again, this is going to be great for those metering applications that need LCD, as well as things like thermostats or electronic shelf labels. Power or battery life is a big topic in microcontroller application development. Many applications like flow and heat meters require 10 years of battery life off a single coin cell battery. To achieve this extraordinary battery life, it is important to realize that power is more than just one number. Let's take a closer look. First, standby power specifications are critical. Most microcontroller applications spend a majority of the time in a standby mode, waiting for a real-time clock or external interrupt to wake them up and take measurements or do some type of processing. Based on our years of leadership in ultra-low power, it is clear that the MCU often spends between 80 and 99% of the time in standby modes. As a result, standby power matters a lot, and the MSP430 FR4x and MSP430 FR2x microcontrollers offer as low as 770 nanoamps with the real-time clock enabled. This is among the best in the industry. Second, many microcontroller applications require a segmented LCD for communicating with the external world. These controllers need to be able to maintain contrast levels when the CPU isn't running and cannot take away from an application's ability to last for years on a single battery. The MSP430 FR4x actually integrates an LCD controller with an integrated charge pump. With an LCD running in standby mode, the MSP430 FR4x is the world's lowest power, consuming under 1 microamp. This is in addition to maintain contrast control and reduce bill of material costs. What's more, the MSP430 FR2x and MSP430 FR4x feature a low-power ADC to improve efficiency when measuring real-time analog signals. Third, many applications want to record data. By recording data, the application can reference it later in comparisons or calculations, or save it for transmission. For example, a heat meter has to record temperature data throughout the day for billing purposes. FRAM enables a huge power savings when recording data, 250 times less power for each bit recorded. Finally, active processing power is important as long as it is kept in balance with the other power specifications. Most microcontroller applications are completing basic decision-making, basic math operations, and driving digital communication interfaces for a very short period of time and then quickly going back to sleep. It is very important to consider all four areas of power consumption when considering total battery life, and the MSP430 FR4x and MSP430 FR2x series were designed with these areas in mind. Let's take a look at some examples. Think about a home. As technology continues to get smarter, we are seeing more opportunities for human-to-machine interaction. Thermostats that once could only change temperature can set schedules and connect to the internet. Video game controllers that once had 8 buttons now might have 30. The MSP430 FR4x and MSP430 FR2x can add value to these applications by offering a minimized system footprint and minimized power consumption. Let's take a look at some advantages in smart metering and remote control applications. First, an electricity meter. These meters could be found countlessly spread across the world. The number is even greater when you think of meters for water or even heat. Many times, solutions for metering require separate certifications of the MCU doing metrology and that doing wireless connectivity. The MSP430 FR4x can be perfect for such a solution. It can connect to TI analog front ends and control the LCD at the same time. This can in fact wake up a bigger microcontroller that could be handling the wireless stack on a set interval, which would reduce power consumption. What's more, the MSP430 FR4x could be sleeping and still maintain LCD contrast for customer or utility readings due to an integrated charge pump. Throw in an integrated ADC and analog temperature sensors could be measured directly to monitor the system for overheating. The MSP430 FR2x can add tremendous value to things like remote controls in a similar way to the gaming controller described above. As more buttons are needed, a higher input device is needed, and that doesn't always mean a larger memory footprint is required. What is even better about the FR2x series is that it features IR modulation logic. FSK or ASK modulation is typically handled in software, which could take many cycles and decrease battery life. With the MSP430 FR2x, this process is greatly simplified with the on-chip circuitry. In remote controls that could use a segmented LCD to display more information, such as those used as universal controllers or air conditioning controllers, the MSP430 FR4x can help. It adds an integrated LCD controller onto the already rich feature set of the FR2x MCUs. As described earlier, this is the lowest power microcontroller with an integrated LCD driver and can also maintain contrast while controlling up to 256 segments in standby mode. The best part is that LCD hardware layout can be simplified since the LCD pins on the microcontroller can be mapped with software. This is critical on a board where the LCD is likely the largest component and space is limited. Thanks for joining the first part of this MSP430 FR4x and MSP430 FR2x workshop. Please check out the second video in the series for information on the clocking and core modules found in these MCU series.